To take us further, here we're going to look at oxidation number. So oxidation number is the apparent charge an atom will have in a compound or ion if all bonds were completely ionic. It is the apparent charge an atom will have in a compound. So that charge that an atom will have in a compound or in an ion, if the bonds were ionic, were completely ionic, that charge that an atom will have is referred to as the oxidation number. So as regards to how to write chemical formulas, we are going to look at the oxidation number of the first 20 elements, right? So you know that elements are arranged in order of their atomic number and they are arranged in the periodic table. So in the periodic table, we have 8 groups and 7 periods. So we have group 1, we have group 2, we have group 3, we have group 4, group 5, group 6, group 7, and group 8, right? Or group 0. It is called group 8 or group 0. Then we have period 1, period 2, period 3, period 4, period 5, 6, and period 7, right? So in the periodic table, it's very important that you should know that from up to down, from top to down is your group, right? So these are the groups. Group from up to down is group. So this is group 5, this is group 6, this is group 7, and this is group 8 or group 0, right? Then from left to right is your period. So this is period 1, right? This is period 2, this is period 3, right? This is period 4, this is period 5, this is period 6, right? And this is period 7. So from up to down is group, then from left to right is the period, right? So the first 20 elements, the first element is what? Hydrogen. And then we have helium. So hydrogen is in group 1, period 1. Helium is in group 8, period 1, right? Hydrogen, helium. And then we move to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and then lastly calcium. So these are the first 20 elements, and this is how they are arranged in the periodic table. So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, then calcium, right? So the oxidation number of elements in group 1 is +1 because they are in group 1, right? So the oxidation number is what? +1. The oxidation number of elements in group 2 is +2. The oxidation number of elements in group 3 is +3. The oxidation number of elements in group 4 is +2 or what? Or +4. And these are what? Metalloids. They are referred to as metalloids. From group 3 to the left, from group 3 to this side, they are metals. So group 1, group 2, group 3 are metals. It's very important that you know this. All these are metals. Group 1, group 2, group 3, they are metals. They are metals because they are ionized by the loss of electrons. These are metalloids. Then from group 5 to group 7, they are non-metals. Then group 8 are noble gases or the noble elements, right? So the oxidation number of elements in group 5 ranges from -3 to +5 right? Ranges from -3 to +5. Oxidation number of elements here ranges is -2. It can be 0, it can be plus 2, it can be 4, it can be 6, but mostly 2, right? Minus 2. The oxidation number of elements here is minus 1. So how do we get the oxidation number of elements in group 5? It is simply 5 minus 8. 5 minus 8 will give you minus 3, right? So it is either minus 3 or it ranges to plus 5. Then the oxidation number of the elements in group 6 is minus 2. The oxidation number of elements in group 7 is minus 1. Then the oxidation number of elements in group 8 is 0, right? It means that they have no apparent charge. So again, oxidation number is the apparent charge an atom will have in a compound or ion if all bonds were completely ionic. So the apparent charge that hydrogen, lithium, sodium, and potassium will have in a compound is plus 1. The apparent charge that beryllium, magnesium, and calcium will have in a compound or ion is what? Plus 2. The apparent charge that boron, aluminum will have in a compound or in an ion is what? Plus 3. So all this is very important, right? So I can decide to ask you, what's the oxidation number of chlorine in sodium chloride? So the oxidation number of chlorine in this compound is minus 1, right? Because chlorine is in what? Group 7. 7 minus 8 will give you what? Minus 1. 6 minus 8 will give you minus 2, right? So this is very important.